This is the real-time rows, and this is an absolutely ridiculous problem. It cannot be done in 2 minutes. If you get this question on the test, you should skip it. You should absolutely not solve it. But as long as we're here, let's solve it. So what they ask for is the distance between a point and a line. First of all, not obvious at all or easy at all to calculate the distance between a point and a line, right? To calculate distance, you need 2 points. But when you have a point and a line, so like we have here, for example, I'm just going to draw this very loosely. We have a super steep line, something like that, right, with a positive intercept. And then we have a point 10, 4, somewhere over here. And it says, what's the distance between the point and the line? Well, there's multiple distances between the point and the line, right? Like this distance is different from that one, it's different from this one, it's different from that one. They must mean what is the shortest distance between the line. In fact, that is what they mean. What is the shortest distance? Now, you need to know that the shortest distance between a point and a line occurs when the distance from the point to the line, or when the line that connects them is perpendicular. Right? So now knowing that, what we actually want to do is so that gives you 2 points. What we need to do is we need to figure out the slope of the line that they gave us. Then we need to make a new line which goes through the other point, goes through this point, and has the inverse of that slope. Right? It goes slope minus 1, inverse slope, and it goes through the point 10, 4. That's going to give you a new line. We need to take those 2 lines, which will give you a system of equations, and we need to solve that system of equations to get an x-coordinate and a y-coordinate. And that will be the x-coordinate and y-coordinate of that point. Then we need to use the distance formula on these 2 points. It took me 2 minutes just to explain what I'm going to do. So first of all, the slope of the original line is 4. So the slope of the new line will be the inverse of that, which will be negative 1/4. That's your inverse slope. Now I'm going to use point slope form. Then I'm going to use the coordinate 10, 4 to generate a line. So you can generate a new equation, which is y minus 4 equals negative 1/4 x minus 10. Right, so I took y minus y coordinate equals slope times x minus x coordinate. That's point slope form. Then what you need to do is do a substitution. So I'm going to take the 4x, y equals 4x plus 9, and I'm going to shove that in here. So you get 4x plus 9 minus 4 equals negative 1/4 x minus 10. And if you solve that, what you will get is x equals negative 10/17. Now you need to plug that back in to the x-coordinate here so you can get the y-coordinate back out. So you get y equals 4 times negative 10/17 plus 9. So y must equal 113/17. This is a place where if you have a nice graphing calculator, this is really where you want to leverage that. So suppose you got that. Now we're going to do point slope form between this point. So think of this as the x-coordinate, the y-coordinate of a new point. And here's the x-coordinate and y-coordinate of the original point. And we're going to do the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. Take the square root of all that, and that is the distance between these 2 points. So let's plug in. We get 10 minus negative 10/17, ridiculous, all of that squared, plus 4 minus 113/17, still ridiculous. Take the square root of all of that, and what you end up with is 45 over root 17, which isn't even simplified. There shouldn't be a radical denominator. But that is an answer choice. Whew, thankfully, that is an answer choice.